So in this, we will look at some circuits and related questions. Question number one. This is a DC circuit booklet. If you do not have it, I'm planning to send it in the group. So number one says, in which circuit the lamp is brightest? The lamp is brightest when it gets maximum current. So these two resistors in parallel draw equal current from the battery, and these two currents combine here, and this gives the light bulb maximum current. This is the diode symbol. It allows current to go in one direction only. Potential divider, one LDR and thermistor used. So which conditions give the smallest voltage? So let's look at the behavior of the two components. They both have decrease in resistance upon the conditions met. The thermistor, when the temperature increases, the resistance decreases and vice versa. In LDR, when the light increases, the resistance decreases and vice versa. So we are looking at the voltage across LDR, and in a potential divider, if the resistance increases, the potential difference across that component increases as well, because V is equal to IR and V makes it directly proportional to R. So we want maximum resistance across LDR. That means it should have a light to have its resistance maximum. So light ones are considered. First, reject A and C. Now LDR will have, which needs to have minimum resistance so that all the potential difference, sorry, we are looking for smallest voltage. Sorry, I do apologize. So for LDR, the smallest voltage across this will only be possible when the light increases, the resistance decreases. So when the resistance decreases, that means the potential difference across this will decrease. Now we want the maximum potential across LDR, and the temperature increases, the resistance decreases. And when the temperature is less, the resistance will be maximum. Maximum resistance across a thermistor will give maximum voltage across it. So maximum voltage across thermistor will give minimum voltage across this. So that's why we need to have cold and light conditions to have minimum voltage across LDR. So in this question, which circuit is correct? We can't have the voltage across voltage in series. Voltage in series wrong here. Ammeter is correct. Voltage is correct, but it is measuring the voltage of the battery. We want the voltage across the light bulb, so we want to connect it here. So B is the correct choice. Here, voltmeter should read 3. So if we connect this, the voltmeter reading here, what's going to happen? It's going to measure 6 volts, and because these two resistors are connected in series and then they are identical and then they are going back here, so this circuit, the D and C and all these three resistors, becomes irrelevant. So for these two resistors connected in series, they will divide the voltage equally because they're identical. It says here. That means 3 volts here, 3 volts here. So if you place the L point here, that will read 3 volts. That's the requirement. And in this question, so when we adjust R to 6, again, the resistors becomes equal. They equally divide the voltage. So it will be 3 and 3. So the V2 will increase. So we look for increase here. and V1 will decrease from the voltage of 6 watts. Well, it wasn't 6, but it was something less than 6, but not 3. And then it will decrease to 3 because the voltage here will increase to 6. Which circuit resembles this arrangement? So we have lamps, 2 light bulbs, and 2 batteries, 2 batteries. Why this one is wrong? Yes, the lamps are correct, but look at the batteries. They're put the wrong way, facing each other. 0 voltage. Equivalent resistance can be calculated using the formula you have been told before. It comes out to be 7.5. 1 over 15 plus 1 over 30 plus 1 over 30, and then reciprocal of the answer. So this one, again, a potential divider circuit, and it should read 7.2, the voltmeter. So we will just focus on B is the correct choice. Why? Because of this relationship. We have the voltage output as V2 equals the voltage input as 12 volts, and the resistor across which we're measuring the voltage, which is 6 ohms, 6 goes here, and the total resistance of the circuit, which is 6 plus 10, both connected in series. So 6 divided 10 multiplied 12 gives you 7.2. Where should an ammeter be connected to measure the smallest current? Well, the current starts from here and it divides into this and this path. The current that goes from 20 ohm will be less than the 10 ohms, so 20 ohm will be the smallest current. Here at at this point, the current becomes the sum of the current coming from 10 ohm and 20 ohm, so it will be more than this. So D will be the A current coming in, B current coming out, the both same. B and C are the only ones left. C will have smallest current because of high resistance. So the resistance is this, current is this, and potential difference across this one. Well, it's very tricky, but very simple. You multiply 30 with 0.6, that gives you 18. And then 18 volts is the potential difference across both resistors because they are connected in parallel. So this is the choice. And this one, another tricky question, but very quick, very simple. Look at the total voltage and look at the resistors connected in series. Their potential differences should sum equal to 40. V is unknown. 40 minus 18 minus 10 gives you 12 volts. So V will be 12. Fuse and diode are connected here. The only one with the fuse and diode. So here, which one is correct? The current is coming from here, I1, and then it splits into I2 and I3 and combines back as I4. So I4 should be equal to I2 plus I3. Let's look why A, B, C are wrong. In A, I1 is equal to I2 minus I3. No, it should be I2 plus I3. In B, I2 is equal to I1 plus I4, that is Pollux. C, I3 is equal to I4 minus I1, that is also Pollux. 15. Which one is corrected to measure potential difference and current across resistor? So this one, because the light bulb, potential difference and voltage across light bulb. So this one, because the V is measuring the potential difference across the light bulb, and A is measuring the current going through the light bulb. The total current will be measured in this one, not the one from the light bulb, and the others are wrong anyway because of the voltage setup, potential difference setup. In this, the voltmeter will actually measure the total potential difference, the total voltage. In this one, which part is potential divider? The part which has two resistors in series is a potential divider, and that activates this buzzer by magnetizing this if the current is enough. Here, what's the value? What component is at X? Well, we have 6 volts and 12 volts output here. To turn the light bulb on, we should have a transformer, step-up transformer. Number 18. So what happens when the switch Y is closed? So when switch Y is closed, this circuit is activated. The switch P, which was originally on, and lamp P was on, Q and R were off because this switch was on. It's a relay magnetic switch which operates due to the switch Y when it turns on. When switch Y is turned on, this thing magnetizes, attracts this switch comes on, the light bulbs are on, and the brightness of P will still be normal because it is connected in parallel with the two light bulbs, but the light bulb Q and R will be dim because they are connected in series, so they will be getting half the voltage as does the P. That's why. Now, one might ask why P won't dim when we connect extra light bulbs. It is because of the parallel arrangement. The P's voltage is not decreased due to this part of the circuit. P gets the same voltage from the battery, so it stays normal as long as the battery lasts. In this circuit, we have to verify which one is correct. So we can see that I naught is the current coming, total current, and I naught is coming here, and then it's dividing into this and this. Current at X and current at reading. So which readings are shown? Sorry, the question says which readings are shown on the ammeter X. So the X will be total current coming here, I naught, minus the current going from this resistor, I1. So I naught minus I1. And what is the value at Y voltmeter? Well, Y voltmeter will have this part's potential difference, total potential difference, minus this one. It is not affected by this part of the, because these two resistors have the same voltage. And this arrangement with this arrangement divides the voltage. So whatever the voltage comes here, this will get this minus this. So E minus V naught. Correct symbols, fixed resistor and potential difference measurements, voltage across the fixed resistor and current from the circuit. C. Why the other ones are wrong? Because of this voltmeter is wrong. Here the voltmeter reads the total voltage, and here the voltmeter is wrong again. Even the ammeter is wrong. I1, I2, I3, I4, all currents, which is correct? Well, we have I1 equals I4. First thing we should look for, so A and B. Now, I3 and I2 are not equal because different resistors. So I3 seems greater than I2 because of the less resistance. And that's the thing. I2 is greater than I3. No, I3 is greater than I2. So B is the choice. Gives the greatest ammeter readings. So if you have the resistors in parallel, forget about everything else and just follow this D. Reading is 1 amp here. When you connect it in such a way that it should read 2 amps. When you connect two light bulbs in parallel, the total current will increase to 2 amps because each light bulb operates on 1 amp, gives 1 amp here. The 1 amp from this light bulb and 1 amp from this light bulb will combine here. Now, why the light bulbs get equal current? Because they are connected in parallel, i.e., they are connected equally to the voltage source. So they both get the same voltage and the same current flows through them. Taking the opportunity, let's discuss these circuits as well. So we have two parallel batteries and the current will be the same. We have two series connected, so the current will decrease. And again, the current will stay the same because of the two batteries. Here, the current will decrease because one battery operates two lights. So the current is equal in this circuit because the current remains same and the potential difference is in this circuit. So Q and P is the correct choice. So we have I1 and I2 and it has three resistors, different values. So that means I1 and I2 can't be equal. But V1 and V2 will be equal because they're connected in parallel. Whatever voltage is given to them, they will have the same across. So I1 not I2, V1 equal V2. What's the smallest current? Well, we have a current coming here, passing through 50, and then it splits into two parts. 10 ohm gets more current, 30 less, so that's why 30 is the smallest. Then coming back here, the current combines again. So these resistors have the same, the current equally divided among them. So 30 ohm will have the minimum current. The 40 ohm resistors, both when they are equivalent, they make the equivalent resistance as 20 ohms. So the current, according to the 20 ohm, will pass through both of them. So we have this arrangement. What's the current? Well, the current is equal to V over R. V is 10, R is 2 kilo ohms. 10 divided 2 kilo gives you 5 milliohms. When kilo is denominator, it becomes milli as numerator. Don't need to use the 2000 and then get confused about it. Just do 10 divided 2 equals 5. Change kilo into milli, 5 milliamps. We have 4 and 2 ohm resistors in 12-volt battery. And what's the potential difference across 2 ohm resistor? Because, well, we can use this relationship or we can just use intuition. We can see that 4 and 2 have a ratio 2 into 1. Divide 12 into 2 into 1 gives you 4. Try 2 are 8 and 4. So 8 will be here and 4 will be here. Rectifying diode is here. This is the rectifying diode. Nothing, no other circuit contains this. So D is the choice. So what happens when we close this switch? At the moment, total resistance is 6 ohms. So the current is 6 divided 6, 1 amp. When we connect this part of the circuit becomes irrelevant because of the short circuit here. So the resistance becomes 3 ohms. V is 6. 6 divided 3 gives you 2 amps. So 1 when open, 2 when closed is the correct choice. This is repeat, same as above. Now, this one, student tests the circuit, press button telephone. It's an old system with a lamp and a battery. So if we connect Which single switch can press to make the lamp light? It's switch number 5, because look at switch number 5. This is the battery that connects this 5 back to the light bulb. So the switch 5 connects the light bulb to the battery. 6 volts in series with 4 ohms. The current will be 6 divided 4, 1.5. 6 and 12 connected in parallel. If 6 ohm draws 4 amps, the potential difference across this becomes 6 4s 24. 24 potential difference means 24 here. 24 divided 12 means 2 amp will be drawn by this resistor. 4 plus 2, 6. 6 will be the reading of the ammeter. This circuit resembles this one. Look at the two cells connected in series, switch, resistor, and the resistor goes back to the, what does the resistor do? Look, the resistor is connected here and it goes back to the battery. So resistor goes back to the battery. 3 kilowatts, energy 20 cents per kilowatt, and used for 5 hours. Multiply 5 hours with 3 kilowatts to make kilowatt hours, that is 15 kilowatt hours. Multiply 15 with 20 cents to get 300 cents. Smallest current, well, the current passes through 2 ohms, splits into this and this. More higher resistance will grow the smallest current. I1 should be equal to I2 plus I3 plus I4, and that is here. That's the only choice. All others are wrong because that's the only thing happening here. Current coming from a battery, 3 lamps in parallel. So 3 lamps draw equal current. Or even if they don't draw equal current, the sum of their current will be the current coming from the battery. So again, we resolve these two resistors into equivalent resistance. That gives us 3 ohm. 3 ohm plus 3 ohm gives you how much? 3 ohm plus 3 ohm gives you 6 ohm, and 6 means 1 amp current. Now you know the current coming from the battery is 1 amp. 1 amp is divided into these two identical resistors, so half going each way. Half means 0.5, so 0.5 is the choice. So we have current diagram and we want to know voltmeter readings in the circuit here. The current will increase, the potential difference will not. Why? Because the resistors are connected in parallel now. One resistor is added, it will draw its own current from the battery. The current will increase. So A increases. Potential difference, well, potential difference is measuring the total potential difference across the battery as well as the resistor. Still doing the same thing. So potential difference will still be the same, i.e. 3 volts. So if you have 1 amp current and you want to make it 2 amps, you just connect the same lamps and the lamp, similar lamp in parallel, you will get the current twice. Diode and fixed resistor, diode, fixed resistor. Lamp, diode, no LDR or LDR. And again, this is LDR, this is LDR, this is a diode, this is a different diode, and this is a resistor. So this is the only one. So this one, tricky one, carefully watch how it goes. First of all, it says when you place the M at X, you get 6.6 amps. That means 0.6 amp times 10 gives us the voltage. Voltage will become as 6 volts, like it is calculated. Now we have 6 volts and we connect Y, M to Y. Now the equivalent resistance comes 30. 6 divides 30 gives you 0.2 amps. Current is smallest at B because the total current coming here passing through a larger resistor gives it a smaller value. So in here, which circuit is correct? Battery is connected to right way, radio works. So battery, diode. If the battery is connected wrong way, there is no current. So you should connect a diode in the way of the current. This is where the diode is not allowing anything to go. This is where the diode is put the wrong way around. This is where the diode is put the allowing the not allowing any current. So this is the only choice. Diode connected on the wire connecting the radio to the terminal of the battery. Here we have again same, we have repeated this question, and one reading will be 1 because current will be double and voltage will be the same. And that's it. Thank you so much. If you can, by all means, subscribe so that you should know what's coming next. There will be plenty of physics, same solutions coming. Thank you.